So what's up everybody, here's Kevin Nivek and we're gonna keep going with our study of Python. And here what we're gonna do is go to Harvard Python Programming Introduction. As y'all know, we was doing about Python programming using the Microsoft, but there I don't know why, but the course I was doing disappears. I don't know how and when disappears the shade of the course I was doing. And what we're gonna do is just find another way to study, and I will use the Harvard a free program to you know how works the Python, right? So let's go. I will go into libraries and here, because exceptions and this part here I already know that. So what I'm gonna do is keep going, and the part I think is good for me. All right. So let's go here, and let's try it. Here is a free one, so you don't need to pay it. If you want to get some certification, you need to pay it, right? But if you don't want it, that's it. You can go and don't need to what the heck? Okay. Okay. Now it's good. Let's go. Video. What is this shit? What is that? Let me check. Video. I don't want a certification, baby. I just want a course. I don't care about it. Lecture. Oh, libraries. What the heck? All right, let me what is the full video? Let's see. It's 1 hour of course, baby. That's so intense.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on libraries. So libraries are generally files of code that other people have written that you can use in your own programs, or a library is code that you've written that you can use in your own program, but maybe not just this program, but another and another as well. So Python supports exactly this idea, this ability to share code with others, share code across your own projects, and it does so by way of what it calls module. A module in Python is just a library that typically has one or more functions or other features built into it. Generally, the purpose of a library, or a module specifically, is to encourage reusability of code. If you find yourself using the same types of functions again and again, the same functionality, if you find yourself copying and pasting from an old project into your new project, odds are there's an opportunity there to factor out that code that you keep copying and pasting, that you keep reusing, and put it into a library that you can then load into your programs moving forward, so as to not just copy and paste it and have all these different copies all over. So what are some of the modules or libraries that Python comes with? Well, Python comes with a random library, literally, which is to say that when you install the Python interpreter on your Mac or PC or somewhere in the cloud, not only do you get Python, you get a whole bunch of modules as well. Now, these modules provide you with functions that you don't have access to just by default, like you do print and input. Print and input and other such functions just work in Python. But sometimes functions are tucked away in these modules, so you have to be more deliberate about loading them into the computer's memory. So somewhere on the computer's hard drive, once you've installed Python, there is also, it turns out, a file probably called random.py that someone else wrote, probably long ago, but that you have access to. And in that random.py file, there's probably one or more functions that you yourself can use in order to do things randomly. That is to say, how could you flip a coin in a program in Python? How could you pick a random number between 1 and 10 in Python? Well, you need a bit of randomness. And while you could figure out mathematically how to write functions like that yourself, it's a lot easier to stand on the shoulders of others who've already solved that problem for you, so you can focus on the problem that you yourself want to solve. So for documentation on most any Python module, you go to the official Python docs, and you go to a URL like this where the documentation for that specific module lives. And within the documentation, you'll see a list of the functions or other functionality that some module provides. But how do you go about loading a module into your own program so that you can use the functions in that module? Well, we need a new keyword in Python, and namely it's import. The import keyword in Python allows you to import the contents of, the functions from, some module in Python. Well, how might I go about using this in practice? Well, let me propose that there exists in that random module this function, among others. So I have copied and pasted from the documentation this summary of a function called choice. Now, the function exists in the random module, so to speak, not a random module, the random module. And so generally the documentation describes it fully like this. Random.choice is how you would technically call this function, though we'll see alternatives to that. In parentheses, there is a parameter called seq for sequence, and sequence generally means a list or something that is list-like, if you have a list of numbers or strings or anything else, and the documentation elaborates. Well, how can I go about using this function to solve perhaps a familiar problem? Well, let me go ahead and open up VS Code here, and let me propose that we implement a program that simulates flipping a coin that in the US has heads or tails, the idea of which is to pick a decision with 50-50 probability, 50% probability of heads, 50% probability of tails, or you can use some other mechanism like that. Well, let me go ahead and open a program with code called generate.py, because I want to start generating a whole bunch of random information, the first of which is just going to be a coin toss. Now, how do I go about using that function? Well, I first have to import the random library. So literally the first, or among the first lines of my file, should be import random. And that just gives me access to all of the functions in that specific module. Now suppose I want to flip a coin. Well, I can do random.choice per the documentation a moment ago, and that again takes a sequence. What's a sequence? It's a list or something that's list-like, and we know about lists. We've used lists to iterate over numbers. We've used lists to iterate over students at Hogwarts. Let's go ahead now and iterate over just a list of two sides of a coin. Heads, quote unquote, or tails. Now I could call these anything I want. These are my strings. I just want to simulate a tossing a coin, so I'm just going to say in all lowercase, heads and tails. But notice the syntax. I have heads and tails in double quotes. That's because they're strings. I could also use single quotes so long as I'm consistent. There's a comma between them, which means the list has two elements. There's square brackets to the right and the left, which indicates that this is indeed a list. That's the syntax, recall, for defining a list in Python. And then lastly, there's something more familiar. There's the parentheses outside of those square brackets, but those are just the parentheses that belong to the choice function and specify where its parameter gets passed in. But again, unlike past functions, I have to specify what module this function is in, at least for now, and so I do random.choice to call this specific function. All right, well, it's one thing to flip a coin, picking between those with 50% probability, and that's what random.choice does. It takes in a list, and it returns to you one of those values randomly with equal probability. Because I've passed in 2 items, I've got a 50-50 chance. If I passed in 3 items, it'd be a 33% chance for each of those items, and so forth. Python does the math for you. But I want to store the value of this in a variable, so let's define a variable called coin equals whatever the return value is. So this is indeed like flipping a coin. I'm going to store in a variable called coin whatever that value is, heads or tails. And now, just so I can see what's going on, let's go ahead and print out the value of that string coin. All right, let me go ahead now and run this program in my terminal window. Python of generate.py, enter, and it looks like the first coin toss was the heads. Let's go ahead and run it again, and it looks like it was heads again. Maybe you want to chime into the chat here. If I run it a third time, what's it going to be this time? If you want to type your thoughts in the chat. You might think there's a bug here, but this is probability in action. If I go ahead and hit enter a third time, there, it's actually now tails. And again, 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 heads. Now, if we did this an infinite number of times, it would indeed work out to be 50-50. If we only do it a few times, it might not work out as cleanly. But that's how probabilities indeed work. All right, so I've got that now working. Could I have implemented this in a different way? Well, let me show you an alternative to actually using the import keyword alone, and let me introduce the keyword from in Python.
All right, and that thing he showed here, I think like I need to like download this like a module. I think if I use an import random here, I don't have this random. I think I don't know. If I do the same code, I cannot use that shit or not. import and koi equal random dot choice, and do the same thing he did it. Like what the? I'm using the Portuguese one, English. And I say heads, quotes, tails, quotes, square in this one, and print point. Right, let me run this shit and check what happened. I need to download this shit or no? Okay, I understand that. I need to download this module as he say it. You mean choice? Oh, I use it here, but I don't think. I mistyped it. Oh, it's worked. So I don't need to download that because already have this import random here, but I need to use the right word here. Like I put S here. If I use the right one, I can use the same code he used it.
Using the import keyword alone, and let me introduce the keyword of the using from.
Hello, I'm Mohammed Omar from Egypt. Maybe if we have a variable that its name is basic like choice, if I have a variable called the choice, so I need to differentiate which choice I choose. So I'm gonna choose random.choice.
Yeah, really good instincts. By using the first approach, by just importing random, you're making sure that all of its contents are associated with, are scoped to the random module so that you can have your own choice function. You can have your own choice variable. You can use the same names as all of the functions or variables that are stored inside of that file without them colliding, so to speak. And this is a good thing. In older languages, it was the case that if you imported someone's library, you better hope that you're not using the same functions or variables as they are, because you might in fact have some kind of conflict. Python and certain other languages allow you to scope the names of those functions and variables to the file or the module that they come from, so that's a good thing. But honestly, this is such a short program, or equivalently, maybe I'm using the choice function in so many places, calling random.choice, random.choice, random.choice. It's just making my code longer and longer and longer. Marginally so, but it's just getting ugly and annoying. I can simply import choice and now tighten up my code a little bit. So as with so many decisions in the past, there's not necessarily one right approach or another. It depends, but I think for those very reasons, sometimes it's better to do what we did the first time, which is only import the module so as to retain the scope therein. Well, let me propose that we transition to another function that comes with Python's random module, and that's this here from the documentation, randint. It's a bit hard to say, but it implies get back a random int. And if you read the documentation, it's a random int that's between A and B inclusive. So if you were to pass in 1 for A and 10 for B, you would get back a number between 1 and 10 inclusive, including the 1 and including the 10 potentially, each with a 10% probability. So how might I go about using a program like this? Well, let me come back to my generate.py file. And why don't we go ahead and try generating a random number between 1 and 10? You might do this frequently in the real world when you just want someone to pick a random number. You tell them as much and the human responds. Let's get the computer to do the same here. Let me go ahead and delete my 2 lines of code at the bottom, but keep my import random. And let's go ahead and define a variable, this time called number. Set it equal to the return value of random.randint, and now pass in A, a value of 1, and B, a value of 10. And now let's go ahead and print the number. I'm going to go ahead in my terminal window and run Python of generate.py and hit enter. 4. Python of generate.py and hit enter. 8. Again. 9. Again. 7. Again. 10. Again. 2. Again. And we can do this all day long, and if we add all of those up, they should end up being with 10% probability each. Now, how might you use this information? Well, maybe we're playing a guessing game, or maybe we're trying to randomize the behavior of some character in a game. You can imagine using very simple building blocks like this, just kind of spicing up your program by getting it to do things a little less predictably because you're choosing these values seemingly randomly. And you're deferring to Python to actually do the generation of these numbers using its own algorithms and its own math. Well, what more could we do here? Let me propose that we introduce another function that comes from this random library, yet another that you yourself don't have to implement, shuffle. If you read the documentation for shuffle in the same random module, you'll see that it takes in a list, for instance, of values and just shuffles them up. It randomizes them. Like a deck of cards here, you might shuffle them so as to put them into seemingly random order. Well, how do I use this based on this function's name? Well, let me propose that we go back to VS Code here, and let me go ahead and this time do the following. Because I need to shuffle something like a deck of cards, let me go ahead and not just import.
All right, let me try this rending. Like import, and I want to randomize something. Random 1000. And I can pre-randomize. Let me check. Kill this shit and run. And then run again. Alright, that's cool. When I go here, if I want to check this, it's okay. I can use that. This module is already there inside my PC, I think. I don't know, but I can use this one. I don't need to download it. It's already inside the Python, I think.
Import random, but let me give myself a variable called cards that's going to be of type list. And just so I have something to shuffle, I don't need all 52 cards in a typical deck. I'm just going to shuffle 3 cards, a jack, a queen, and a king. I could call those strings anything I want, but I just wanted a list of some values so as to shuffle them up. That is, randomize the order they're in. Well, how does this now work? If you read the documentation for random.shuffle, you'll see that it shuffles the argument in place. That is, unlike many of the functions we've seen, it doesn't return to a value that contains the shuffled cards in this case. It actually shuffles the list it's given itself. So what this means for my code is that I need to do something like this. Random.shuffle and pass in the variable containing those cards. And then on a final line here, how might I go about printing the cards? Well, I could do this, and I could say print cards. But if I do that, I'm actually going to see Python syntax for lists. And it's just going to format in its own way using commas and the like. I want to print these cards out one at a time just because I think it'll look a little better. So we can use some of our syntax from loops and say something like this. For card in cards, go ahead and print out the current card. So what's now happening here? Line 3, I'm defining a list of 3 cards in this order, jack, queen, king. I'm then shuffling those same cards on line 4. And then on line 5, I'm using a for loop. For each of the cards in that list, print it out one at a time. And because I'm using print, one line at a time. Well, let's see the results. Down here in my terminal window, I'm going to run Python of generate.py and hit enter. Queen, king, jack. Seemingly shuffled because that's not the order I defined earlier. Let's do it again. Queen, king, jack. Okay, that happens to be the same, but let's see. This could just be bad chance. There we go. Jack, queen, king. Doesn't look like it's shuffled, but at least we're getting back different orderings now. Again, jack, queen, king. Not so good. Jack, queen, king. Not so good. This is someone you probably want to play against with cards. Queen, jack, king. There we go. But of course, we only have 3 cards here, so there's not that many permutations we might see. And if we do this over time, we will see all of them. But if we had, of course, 13 or 52 cards, we'd see a lot more permutations instead. So we have now these 3 ways to generate random information. One is simple coin toss if you want to start some kind of athletic event. One, pick a number between 1 and 10 if you want to decide something based on that. And now using shuffle, we can even take in a list of things and shuffle them about so that we get some kind
Cool thing
of random behavior. Well, let me pause here and see if there's any questions yet. These same functions. And consider how we might leverage other types of functionality that aren't necessarily in this specific library here. Well, it turns out that Python also comes with a statistics library, and this contains all sorts of functions for doing things more statistical in nature, namely calculating means or medians or modes or other aspects of a data set that you might want to analyze. So how might we use the statistics module in Python? Well, we might first just take a look at its documentation like any other module in Python Python, and we'll see within that library that there's a whole bunch of functions. And one of those functions is one that's quite simple. It's average, a function that allows you to calculate the average of some numbers that you've passed in. Let me go ahead and in VS Code in my terminal window, open up a new file called average.py. And at the top of this file, I'm going to import a different library this time, namely the statistics module in Python. And now I'm going to go ahead and call a function that I know comes in that module, namely mean, for the average of some values. And I'm going to call statistics.mean. And I'm going to pass into this function mean a list of some values. And let's suppose that I'm quickly trying to calculate what my current grade average is in school. And I did really well on my first test, and I got 100%. And on my second, I did well, but not as well, and I got a 90. And ironically, I'm not very good with math, so I'd like to figure out what my average now is between those two tests. So let me go ahead now and in this list, type in the number 100, 90, thereby passing in a list of two values, two ints, 100 and 90, and outside of those are the parentheses, because of course this is now the argument I'm passing to the function called mean, and this function mean is in the module called statistics. Well, it's not that interesting to just calculate the mean if I don't actually see what it is, so let me additionally pass the return value of that mean function to the print function as usual. Let me now in my terminal window in VS Code type in Python of average.py and hit enter, and voila, as you might expect, my average is 95%. So the difference here is that I'm just using a different module that still comes with Python, but I need to import it instead of, for instance, the random module instead. And this time I know from the documentation that there exists a function called mean. Well, it turns out there's even more functionality that comes with Python and that comes with other modules in Python. And there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally that allow you to provide input not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py, for instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file, but I could. In fact, when you're running programs in a command-line environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py. And I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called sys. And sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module, but we're going to focus on something a little more specific, namely this thing here. It turns out in the sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element is going to be the first word that you typed, the second element is going to be the second word that you typed, and so forth. And by way of this list then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program? So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one, and in the US here it's very common to wear a sticker on your lapel that says, hello, my name is David, so I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then after that, I normally have been in the habit of calling input, storing the return value in a variable, and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv bracket 1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv bracket 1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. All right, let me go down now into my terminal window and run python of name.py. But this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, DAVID separated with a space from the name of the file, so that now when I execute Python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly, at first glance, rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv bracket 1 is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0, the next element is 1, the next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first element actually in that list.
Oh, yeah. I think it's like in C, the name of program.
Indeed, it's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter, and we don't really need to know that because we're using Python itself. But after that, I did type two things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written, and it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv. Let me go ahead and try this. Python, name.py, and no, I'm not giving you my name because at this point I might not even know that you want my name to be typed, so let me hit enter now, and uh-oh, we see now an error. A so-called exception in Python. This one's a new one. This one's an index error that elaborates list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0 because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change...
Let's go, babe. I think in this video I didn't use so much my Visual Studio to type and practice, but I think this is good. I don't want to spend one more 30 minutes to create a video for you guys, so I'm gonna keep this video until here. and after we can keep going of these 26 minutes here. All right, let's go, baby. Let's keep practicing, and that's it. Let's go.